Hello Internet, I'm Guy. This is the second video in the series about making the InclinoClock. In the first episode there I made the walnut case for the whole clock. This is the back side right here, and you can see this little recess here. I've already cut a piece of black acrylic that will go in the back here, and so that will hide all of the electronics. In the front here there will be, of course, the brass clock face and the little smiley face of the inclino gauge and a bunch of dots. So the process today, I'm going to be machining and making a motor mount here that will allow the motor to drop into this hole and be mounted here. And then there'll be an adapter for the motor shaft to connect it to the clock face. And then the clock face behind the brass will be a piece of white acrylic. There's a reason for that, and that'll become clear later. And then on the front of that will be a piece of brass, which this has the blue covering on it right now. Now, as the work proceeds and I start building, Dave and I have a constant dialogue by phone and email and video chat. And what he does is he updates his renderings to reflect how the work is evolving together. So the video that you see on the right shows how it works. And what I forgot to talk about in the last video is that the default action, as you can see here, is this pendulum swinging motion to evoke an old classic pendulum clock. But then in order to get it to show the time, you wave your hand over the top or just touch the little button on there, and it'll come around, as you can see, to the current time, move to that position, stay there for a while so you can see it, and it will actually move to an intermediate position between the dots, so you'll know exactly if it's 11:15. You can kind of get a sense of how far that is moved between the two to show that time. And then it reverts back to pendulum motion again. That's probably going to be another video showing how I program that. But today I'm going to jump in and start engineering all of these parts. So stay with me and enjoy the ride with me. Thanks for watching. So to make the mounting plate here, this is a circular mounting plate that I have in mind here. What I'm going to do is mount the motor to the plate with these 4 screws. Now there's a raised section in every stepper motor, so I'm going to have to make a recess in that plate or just make a hole in it. And then of course 4 more mounting holes to secure it to the wood here, that the bolts will come through from the bottom into this plate. So let's get started on that. I found this scrap of aluminum in my pile. I just sanded it off a little bit with my orbital sander to clean it up. And I'm going to blue it all up here. Measure to center, so that's 2 inches right there. And 2 inches here, close enough. By the way, this is the scribing tool that I made in a previous video. So this is a sewing needle and a brass holder for it. Mark that with a center punch. And then I can go in with a compass and just give me a nice clean circle here. So I can cut this out on the bandsaw and then proceed from there. Okay, I've got that cut out. I'm going to drill a 1/4 inch hole to allow for the motor shaft to clear in here, but more importantly, that 1/4 inch hole will allow me to bolt it to my rotary indexing table for my milling machine, so I can then machine and position all of the mounting holes concentrically so they'll line up perfectly with the motor holes, and also the mounting holes will be symmetrical that go into the wood base. Actually, I've decided to take it for a quick spin on the lathe. I've mounted it with a 1/4 inch bolt, and this is a long bolt known as a pump rod connector for connecting 2 pieces of 1/4 by 20 threaded rod. And that makes it just easier to chuck it up in here. I just want to get this concentric just purely for aesthetic reasons, and I think I actually made this slightly oversized, so I'm going to turn it down a hair. Okay, I've got my rotary table mounted to the mill, and I'm going to center on the 1/4 by 20 hole that I drilled and tapped into the center there when I first bought this. It's a very handy feature to be able to just bolt something straight down into there. So let me get that centered up a little bit. Right about. Okay, I'm going to lock down the X and Y axes of my table and bolt that thing down. What I've done is I've cut a piece of 1/4 inch MDF and using that as a drill through scrap piece, and then I can tighten this down onto there and just drill right through it. So get this torqued down. That's not going anywhere. And re-zero my table, snug that down a little bit so it's tight. Okay, then I need to do the math for the offset and use my DRO to find where the center line is for these holes. So I've determined that the hole spacing across the diameter of the motor is 0.861 radius. So I'm going to now move my x-axis over to 0.861, looking at my DRO. There. Locking down my table. Gotta bring this down. Now I'm using a 3.5 millimeter drill for the 3 millimeter bolts for a NEMA 17 motor. I'm not going to bother with center drilling because I've got wiggle room. It doesn't really matter that much. So now I'm going to turn 90 degrees. And lock that down. Okay, sanity check. Let's get the motor and just eyeball it to see if that looks right. Yes, it does. Okay, so then I'm going to make mounting holes further out. Make sure that they're clear from the radius of the motor here, so they're going to be out further over here. So now I'm using a number 21 drill, which is a 1032 tap drill. Again, I'm not too worried about precision, so I'm not going to center drill this. This is just so that they're all more or less aligned, and I'm going to have a larger hole coming through from the wood into here, so that there's some wiggle room here to center it if I need to. Looks like that drill bit wants to wiggle a little bit. I probably should have used a center drill. Oh dear. If I go in there very gently though, it'll kind of be close enough. Okay, I've got my tap in my tap guide up here. It's in collet chuck. Here's a little tapping fluid. Tap all these out to 1032. Tidy up all the holes with a little bit of a chamfer just to be professional here. It's the little details that separate the men from the boys, I think. Okay. So off camera, I spun it up on the lathe to just give it a nice finish with some Scotch-Brite. And I've just done a sanity check to make sure all my bolts fit in there just fine. One of them's just a hair snug, but it really doesn't matter. That's just to secure the motor. So now the other thing is, the reason I have my step drill here is because all stepper motors have that little bump right in there, and that is close enough to 7/8, and I've marked off 7/8 with my Sharpie here so I know how deep to go. I'm going to jig this up and drill that hole out to 7/8. Change of plan, I decided to use a smaller step drill to start with so that I can drop this in here and center things up. And if I lock my drill press down there, I can use that to now guarantee everything is centered. Come in here and clamp this down very securely because these bits are a large diameter and they will yank a piece of metal right out of your hands. Okay, so now let's go with a moderate speed here. These like a lower speed. So this is the 3/4 inch maximum size. I'm going to go all the way through. All right, that's 3/4. And then we'll take this out and put the bigger one in. I'm going to put some cutting fluid on here this time. That was binding up a little bit before. And again, you can see my mark right here, so I know how deep to go, which is the third one from the top, is the other way that I gauge things. So here we go. Final pass. I believe that's it. Okay, that's nice and drilled out, and it turns out it fits just beautifully on there. So all I have to do is plop these screws in there, and this is the first assembly that's completed that's a mechanical piece of assembly here for the clock. So the proof of the pudding is, does the motor fit in there and settle in properly? Yes, it does, and in fact that's indexed pretty darn solid. So now I'm going to use a transfer punch and punch all of these, holding these straight up and down like that. Mark those and drill them out for a number 10 clearance with a little generous room size. So instead of using number 7, I'll be using a number 6 drill here, just to have a little wiggle room. All right, so that will just drop right in there. Okay, so I've got the motor mount done, but now I need to connect this little shaft to the 1/4 inch white acrylic and the brass on the front of that. So I need to make a little adapter that fits on here that will connect these two together. So I've got a piece of 1.5 inch aluminum stock here, and what I'm going to do is bore it out for this 5mm diameter, but in these I'm going to be drilling a 1/4 inch hole to mount them onto my rotary table. So the outer surface of this, if you look at it around this way, will have a little raised section here that is a 1/4 inch diameter that these will index onto. So I'm going to do this on the fly. I haven't done any drawings. I'm just going to wing it as I go. But the primary goal here is to have concentricity between this shaft and these two discs so they don't go around like this when the clock moves. Okay, so I've cut off a length of 1.5 inch aluminum on my bandsaw. Obvious first step is to surface this end, so here we go. Yep, I think that's good enough. Okay, we've got a good surface. Next step is to drill that hole. Starting with a number 3 center drill. So now I'm going to drill out with a 4.5mm drill bit and work my way up to a 5mm to get precision. Going to go 3/4 of an inch deep, which is what I need. Number 5 drill, a little cutting fluid on this one to make it really nice. And the required sanity check to make sure it fits beautifully. And it does. In fact, it's not quite bottoming out. That's a very tight fit. Just exactly what I wanted. Okay, so now I'm just going to cylindricalize the outside. So yes, I'm using my motorized carriage, and I've set a stop here so that the motor will always stop at that point, which is, I believe, all I need there. That's about 0.75, which is just what I need. Okay. Going in a little bit more. And that second spring pass clearly takes quite a bit off. Notice I'm using my favorite round nose cutter, which leaves a really nice finish on the aluminum. Okay, what I didn't figure out here ahead of time is that there's not enough difference between a 5mm hole and the 0.25 inch raised section that I need out here that will index into the acrylic. So plan B is I'm going to use some 0.25 1/4 inch steel rod, drop that in a 1/4 inch or so, and then finish that out so it's sticking out into the acrylic here, which is what I should have done at the beginning. I'll just probably glue that right in there. So I'm going to sneak up on the 1/4 inch hole by starting with the next drill size smaller. to a full 250 1/4" drill bit. Yeah, that's going to be good enough if I glue that in there. All right, so I know my acrylic is actually measuring around 3/16 roughly. I've got this rod shoved all the way in there, and I'm going to describe that surface so I can see that little mark, and then I'm going to measure off 3/16 from there, minus a hair for fudge factor, and then I'm going to remachine this end right here. So ultimately I'm going to put a couple of flathead number 4, maybe number 6 screws through the acrylic sheet onto this large surface here to secure it onto there. So I don't need a lot of depth here, I only need about a 1/4 inch, and then I can reduce the diameter back here and put a set screw in there to hold it onto the motor shaft. So I'm going to spin it up very slowly here and use my ruler here to put a mark right about the 1/4 inch right there, roughly. Now that's not a very good mark, is it? Let me use the other end of the Sharpie here so I can see that better. Here's my ruler, right there. That's what I want to see. Okay, so what I'm going to do now is go in with a parting tool and remove all of this material along here next. Okay, so I'm just about to part this off over here, and then I'll flip it over and tidy it up. There it is. Let's just clean up that bottom hole a little bit. And then I'm going to clean that outside surface up a little bit too. So now I'm just going to clean this up with a lathe file. Edging right up against the jaws, a little scary there. Maybe a little Scotch-Brite to tidy all of that up. So back to the steel pin, I'm just going to part this off. There we go. Got that flipped around. I'm just going to clean up the end. All right, that's the little pin. So let's have a look here. That will drop in and go right into that sheet of acrylic. That's what I want it to do. Okay, so this is where that little stub will stick out. And then I need to put a couple of number 4 bolts in there to secure the front clock face to this motor adapter. So these are number 4 40 flathead screws that will go right into the acrylic and embed down that far. So first of all, I have to find center. So creep down here and wiggle around a little bit. And That looks good. Okay, lock down my axes, and then I'm going to zero my DRO. Take this out of there, go 1/2 inch off to each side. All right, that's locked in. So now I'm going to do some center drilling. So this is a number 1 center drill. Now I'm going to move over to minus 0.5. Okay, one more hole. All right, number 4 tap drill. And tapping in that number 4 thread there with a tap guide in the collet. Okay, center drill for a 632 set screw to secure it to the motor shaft. Okay, there's the motor, and here's the mount for the faceplate, or the clock face, if you will. And so now I'm going to put a little glue on the little pin here. Do that off camera so I don't spill it. There we go. See a little bit of blue gunk there. And that is glued in. Oh, sorry, my hand was in the way. I didn't see that. So now the other thing is that there will be 2 number 4 screws. I can't get my hands out of the way of this shot. There we go. So there'll be a couple of number 4 screws that will go in there and secure the acrylic onto the plate. And then this gets screwed onto the motor. So this is the flat of the shaft here. And I've got the set screw right here. So that will drop on there and tighten down, and this will drop in there and get screwed in like that, and there we go. So that's it for this video. Next video that I put out in about a week, I'll be machining the brass faceplate, which you can see rendered here in Dave's rendering. So I'll be machining that smiley face and all the little dots and the whole faceplate, and probably mounting the whole cover plate, which will be clear acrylic with those 12 brass screws as shown. So if you haven't subscribed already, please do so and hit the notification bell so you'll know when I release another video. And also, if you want to give me a like or a super thanks or support me on Patreon, I welcome that too. I could use all your support. See you next time.